Hello and welcome to another one. This one is vectors. I think foundation lesson 23. Okay, there's two types of vectors. There's vectors that have arrows and like this, and they're called A, and they go from A to B, and we'll explore that further in a moment. So if you go from A to B, you go up the vector little a. Now, a vector is a distance in a given direction. But the first kind of vectors we'll look at is column vectors. And you will be asked to add and subtract column vectors. And this is what they mean. A column vector is written like this. And we've got something like this, 3 to 2. Now the top number represents the x value and the bottom number represents the y value. So if we just quickly draw, we don't have to do any numbers, we can count, yeah. If we could quickly draw the x and y coordinates on this piece of graph paper, like that. So we've got the y that goes up and down and the x that goes from side to side. Now, if the x is a positive number, it means we move from our starting position to the right. So a positive number moves to the right. If it's a negative number, we move to the left. And the y, if it's a positive number, we move up. And if it's a negative number, we move down, just as the numbers on the xy axis do. So what we're going to do is we're going to start from point A, there, and we're going to move from point A a vector of, say, 5 and 3. So what this means, and label where we end up as B. What this means is we go 5 along, so 1, 2, 3, 4, 5, and the y is positive, so we go 3 up, 1, 2, 3, and we end up there, which is going to be the B. And the actual vector that we're moving is in this direction, yeah, from A to B, going up there. You don't have to name it, and this can be a shape. Yeah, we could have a triangle like this, and we're going to move the triangle in vector, what should we put? Should we put 6 minus 8? So we're going to move the whole triangle that distance. So take a corner and go 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8. So we need to get rid of that one because it's in the way. Right. So we've gone along 6 and down 8, and that's where we 1, 2, 3, 5, 6, 7, 8 there. So that will be the top corner, and then you can just copy this shape where you started. It's 3 down, 2, 3, and the triangle A has been moved by the column vector 6 minus 8, and it ends up at B. Now the other kind of vectors that we can use with problems with column vectors is adding and subtracting. So if we've got vector A, and we shall call it 3, 2, our favourite, and we're going to add vector B, and we'll call that 4, 7. Or we simply add the x's together and add the y's together, so that will come out at 7 and 9. And what we've done there, if we started at position A there, we've gone along 3 and up 2 to get to there, and then we've added along 4 and up 7 to get to there. So that is our vector when we've added the two together. And you see we've gone along 3 and 4, make 7 on the x, and 2 and 7 make 9 on the y. Now when you're adding these things together, they might ask you to do a plus 2b, and we use the a and b up there. Yeah, so you put the a down, yeah, we know what that is, 3, 2, and then we'll add 2b. So this is b, 4, 7, so 2b is just twice as much as that, so that's going to be 8, 14, and 3 and 8 equal 11, and 2 and 14 equal 16. There you go. So we've gone along 3 up 2, and along 8 up 14. All positive numbers, so nice and straightforward. So we might have this. Here's 1, 3, and 10. And we're going to subtract vector b. And this is minus 2 and 4. And this comes out as 3 minus minus 2, which is the same as 3 plus 2. 3 minus minus 2, it makes 5. And 10 minus 4 is 6. So we can have multiples of vectors that we add together. So let's add 3a minus 2b. Okay, so 3a, what's 3a? 3 times as much as that. So that's going to be 9 and 30 minus twice as much as the b, minus 4 and 8. And that will equal 9 minus minus 4 is 13, and 30 minus 8 is 22. Yeah. Now, the other kind of vectors are the arrows, arrow vectors. Now, if we're going to go from A to B, we could call this vector A, a little a. Sometimes you see it with a line on the top, such as this, but it doesn't make any difference. As long as you can do them, it doesn't matter how you write them. So A to B. Now this is a certain distance in a certain direction. Now if you have something that is twice as long as this in the same direction, so because it's the same direction, it's the same vector as A, but because it's twice as long, it will be 2A. Now because these are multiples of each other, it means they're parallel to each other. And sometimes you have shapes where you, like a parallelogram or trapezium thing, and you've got to prove that they're parallel. So as long as you get one as a multiple of the other, and so we'll have a little short one here, E to F. Now, same direction, it's parallel, only half as big as that one at the top, so therefore this would be half an A. Yeah. And if you have another direction, yeah, we're going this way from F, G, H. That isn't A, but you don't, it could be anything, yeah, but we'll just call it B, yeah. So you have vectors A that always go that way, vectors B that always go that way. Okay, so let's do a triangle and try and work out what a missing vector is. Now, the thing with a missing vector is you can only use what you know. So we go A, B, C, so we label up the corners, and you might get some information like this, that the vector A to B is called A, and the vector A to C is called B. The little letters have no relation to the big letters whatsoever. It could be, this triangle could be X, Y, Z, so therefore, you know, if it was, then X, Y might be equal, you know, you can have X, Y equals vector D or something. You know, it doesn't make any difference what they are. So what we're going to do here is just label them up. Yeah, so A to B is A, and A to C is the vector B. Now find the vector B to C. Okay, now you can't go directly from B to C, but you can work out what direction it is and how long it is by using the other two vectors that we know. So to get from B to C, we're going to have to go around the long way, down to A and then across there. Now the first bit is from B to A, which is the A vector, but we're going against the arrow. We're going the wrong way. So this, when you go against the arrow, this becomes a negative. And then we're down at this point here. So then we've got to get from A to C, and we know that's vector B. So we'll just go, so it's minus A plus B. You could write this round the other way, B minus A. It doesn't make any difference. It looks nicer if you begin with a positive number, that's all. Alright, so let's have a go at this one. So, third triangle, and we'll label it up A, B, C, and we'll give some information that A to B is going to be equal to vector A, and B to C is going to be equal to vector B. So what is A to C? So transfer these onto the triangle. A to B is vector A, B to C is vector B. So A to C, we're going to have to go up that way and down that way. So therefore A to C is going to be equal to A plus B. Nice. Yeah? Now, if we went from C to A, the other way around, we start there, we go up, get backwards up this one, so this will be minus B, and backwards that one, minus A. Yeah. So when you're going against the arrow, it's a minus. When you go with the arrow, it's a plus. You cannot invent names for vectors. Vectors can only be not a product, but it can only be a combination of the vectors we know, and it doesn't matter which way round you go. Right, so here's a trapezium. Now, the bottom of the trapezium is twice as long as the top, so let's label it up A, B, C, D, and move it up a little bit for us so we can, oops, too far, come back. Okay, right, just a bit so that we don't get confused with that. Okay, so let's do some information. So A to B is equal to vector A, B to C is equal to vector B, and D to C is equal to vector 2A. So AB is A, BC is B, and DC is 2A. Now remember I said before that when one vector is a multiple of another, it proves that they are parallel. And in a trapezium, the top and the bottom will be parallel to each other anyway. So, and it means that the vector is in the same direction, but the DC one is twice as long as the AB one. So what shall we find here? So let's find AC. So we start at A, we go along A and down this B. So from A to C will be A plus B. And C to D. C to D is backwards along this one. So it's against the arrow, so it will be minus 2A. And A to D. So that's just from there down to the bottom there. Now we can't go directly there. We've got to go all the way around. Yeah. So that's going to be A plus B minus 2A. And we've got some simplification, some collecting like terms to carry on with. So we've got a plus A and a minus 2A. So that is minus A plus B. And I'll write that as B minus A. Just the other way around. Just the other way around. some more examples here. This one, and this one. So what do we got? We got X, Y, and Z. So information first of all. So let's do Z, Y equals D, X, Y equals C. Find this one, X, Z. So Z, Y equals D. So that equals D. X, Y equals C. So that equals C, and we've got to find what X to Z is. Well, X to Z is simply start at X, go up C and against D, and there you go, C minus D. C minus D, pretty good. Move that up, draw another one. This time we've got a square shape, square. I wonder whether I can actually draw a square for you. Draw a square. Okay. And I'm going to write beside it that this is a square. Now, remember properties of squares, properties of shapes really. Where square, all four sides are the same length and the opposite sides are parallel to each other. So that might help us a bit. So let's go A, B, C, D. Now, AB is equal to a little a there. And BC is equal to a little b there. Now, already, without working out any old vectors, you know that this one here, AD, is going to be equal to a b because it's the same as the one on the right hand side. And DC is going to be equal to a little a. Right, now, let's change the colour and let's draw a line from A to C and see whether we can find that. So let's work out what A to C is. Now, so we can go one of two ways. We can either go round via B or we can go down via D. If we go this way via B, we get A plus B. And if we go the other way down, we get B plus A. So it's exactly the same thing. Perfect. These are level 5 questions, believe it or not, for the GCSE. We go back to black. So, right. So, last one up. We've got some kind of triangle there. Yeah, they're usually triangles and parallelograms and trapeziums and things. So, we'll just label it up and we'll just add one fiddly little element in there. That AB is equal to A. BC is equal to B, and M is the midpoint of BC. Okay, so let's put all that information in, do it in a different colour, and then we'll have a question. Right, so AB is A. There, that's A. BC is B. BC is B. Okay, that's a whole length. Now M is the midpoint, so stick a thing there and call it M. And now because that is the midpoint and the whole length is B, what we can do, we can say, well, that's the same direction but half the distance. So that little bit could be half a B. And this little bit down here now, I know that was originally for the whole thing, but we call this little bit down here half a B as well. Because two halves make a whole. And what we're going to do is find the vector from A to M. Now, we can't go down the bottom because we don't know it. So we're going to have to go up to the B and then down. So the vector AM is going to be equal to A plus half a B. And what about this one? The vector C to A, last one, just for fun, yeah? The vector from C to A. Now we've got two choices. We can go all the way up to B and then down to A, or we could go up to M and down that way because we've just found out what that vector is. So let's do it two ways. So we go all the way up. So we've got half a B and a half a B, which is a whole B. We're going against the arrows, so it's minus B. And then we go in the empty arrows there, which is minus A. Now what happens if we decide to go up there and down that way? Well, the vector of this one from A to M is A plus half a B. Right, so going the other way, we go up this way, there, so we've got minus half a B, and then we're going to go there, so this is minus A minus half a B, and we end up at A. Now if we simplify this, minus half a B and minus half a B makes minus a B, and then there's a minus at the end. So you see the vector is exactly the same thing. No matter which way round the shape you go, it's the same thing. So there you go, a little lesson on vectors.